Okay, I'm going to be doing problem number 71, section 2.1, and on page 61 in the textbook. Linear depreciation. A new machine was purchased by National Textile for $120,000. For income tax purposes, the machine is depreciated linearly over 10 years. That is, the book value of the machine decreases at a constant rate, so at the end of 10 years the book value is 0. And it wants a functional relationship between these two variables, the age of the machine and the value of the machine. And they went ahead and told us to let those two variables be represented by N and V, where N is the age and V is the value. They also tell us it's a linear depreciation, or it's a linear relationship between these two variables. So really I just need 2 points to create my function. And at the beginning the equipment is $120,000, so I have 1 point there. And 10 years later it is $0. I notice that the 0, 120,000 is the v-intercept. So I'm going to create my function using the general model y equals mx plus b, which means I've got to find the slope. So I'm going to start with my first point there and find the difference of my y values divided by, now be careful, I'm going to have to say 0 subtract 10, so that's going to give me a negative 12,000 for my slope. And when I create my function, I'm going to go ahead and use function notation. So my function, my value function, with input n for the age, and using the y equals mx plus b form, only I'm using other letters to represent my variables. I come up with this as my function. Now they want us to graph that, so let's look at the domain of that function. And the domain, and this is a practical domain in this problem. It's a linear function, so in an algebraic sense, the domain is all real numbers. But in this sense, the equipment is depreciated over this 10-year period. So from 0 to 10 is a practical domain. And the values of the equipment will decrease from 120,000 to 0. So all of the possible values for the equipment here in this relationship would be from 0 to 120,000. Okay, now I'm going to go ahead and create my graph. Okay, we have the graph, and notice that on my horizontal axis, that's my input variable, represented by the letter N, the age in years. So I've calibrated that axis from 0 to 10. And along my vertical axis, V for value, and I've calibrated it in dollars. My unit measure there, or my labeling, goes every $20,000. And I've plotted the 2 points that I had, 0, 120,000, and 10, 0. And knowing it's a linear relationship, I can go ahead and draw the line. Now one question, additional question the book has, is that it says to find the book value of the machine at the end of the 6th year. And I can do that on the graph, or at least get an estimate of it. Notice that at n equal to 6, it looks like it's almost at 50,000, but not quite. So what is the value at the 6th year? It's about 50,000. Now, to go ahead and compute it, I'm going to use my function, and I'm going to evaluate that function at the 6th year there. So 12,000 times 6, and then plus the 120,000. And that gives me, let's see, 48,000. So $48,000 is the value of the equipment after 6 years. It is depreciated $12,000 per year for 6 years and has come down from $120,000 to $48,000. Now, I was pretty good on my graph there because we knew it was about 50,000. So that point represents the relationship between the age and the value at that 6-year mark. The last question is find the rate at which the machine is being depreciated each year. So that's part D there. That's my slope. My slope is negative 12,000, or it is depreciating $12,000, or decreasing $12,000 per year.